Hello students, let us discuss some text exercise question based on the ethers. Question number 24. Name of the reagents and the equation for the preparation of following ethers by Williamson synthesis. Here, some name of ethers are given. We need to identify the reactant which should be used in order to prepare this ether by the method Williamson synthesis. So let us do this problem one by one. First one, 1-propoxypropane. First of all, make the structure for 1-propoxypropane. Propane is the word root here. So that means we make 3 carbon propane, and on the first carbon we have to keep the substitute, that is propoxy. So that is 1-propoxypropane. Now we have to prepare this ether by the Williamson synthesis. So first write down the equation for Williamson synthesis, that is RONA plus XR equal to ROR. When you look at the product which is given to us, in this both the alkyl groups are same. That means it is a symmetrical ether. So that means here in the general equation we can keep this both R. If we are not keeping R dash. R dash means both alkyl group are different. Here both the alkyl groups are same, so we are keeping R. So when you look at this product, the general product with our given product, what you can compare from this one? When you compare this one, we will be getting that what will be our R? The R is actually CH3, CH2, CH2. Here it is given C2H5, CH2. That means the propyl group CH3, CH2, CH2 is our R. So from this we got the R here. So what we actually need here, we need the reactant. So what we got the R here, R we got CH3, CH2, CH2. So in the place of this, what we can write, in the place of R we can write CH3, CH2, CH2ONA. And here in the place of this also we can keep here XR. In the place of that X you can keep any halogen. So we are getting Br, that is CH3, CH2, CH2. So what we can say that from this one, by comparing with the general equation with the given product, we can find out the R. Once we find out the R, what is the general equation? From this we can easily compare and we can find out the reactants here. So that is the answer for this problem. Second part, ethoxybenzene. Make the structure for ethoxybenzene. Ethoxybenzene. Here benzene is the word root, main chain. So benzene, and on the first carbon there is a group that is ethoxy. So ethoxybenzene. Now look at here. When you look at this one, ROR, because here both the groups are different. You can see on the both the side of oxygen there are different groups. Therefore we can say R dash. Our ether is ROR dash. So definitely that means our RONA plus R dash X. When you compare this, we will be getting that this part R here, one of the R is a benzene ring and one of the R dash here, that is a ethyl group. So how easily you can frame this product? Because in the Williamson synthesis, RONA plus XR dash give rise to ROR dash. So how easily we can frame the product? What is given to us? The product is given to us. We are finding out the reactant. So better O on the either side when you check, here it is a ethyl group, here it is a benzene group. So that means one can form the ethoxy one can form the alkoxide and the other can form the alkyl halide. So which is the correct one? That is sodium phenoxide, and the ethyl is actually forming the alkyl halide here, that is bromoethane. So this one will be the reactant which gives the product ethoxybenzene. Third one, 2-methoxy 2-methyl propane, which is the word root here, that is propane is the word root. So make the 3 carbon, that is 1, 2, 3. Propane is the word root, and on the second carbon there is one methoxy group and there is one methyl group. So what we can say, 2-methoxy 2-methyl propane, this is the structure. First you have to make the structure. Now look at here, which are the R here. Here 2 are the different R and R dash. How you identify R and R dash? Always point out the oxygen. Now look at on the 2 sides, that is this part will be one of the alkyl group and this part will be other alkyl group. So definitely one of our R and R dash will be the tertiary propyl group, tertiary butyl group, and the other one is actually the methyl group. Now we have to identify that which group will be forming the sodium alkoxide and which one can form the halide. As we have discussed that the tertiary halides does not undergo substitution. Instead of that, it undergoes elimination. So definitely the tertiary part, that is this part, will not be the halide. This part will be the alkoxide. So that means this part ONA, that is sodium alkoxide, commonly called as sodium alkoxide, should be the tertiary alkyl group, should be the sodium alkoxide. And the other part, what is the other part? That is the methyl group. That group will be the primary, because primary halide. So this reaction is the suitable reaction, because when you make this part reverse, when you make it, you will not be going to get this product. Instead of that, we will be getting alkene, because tertiary halides will not give rise to the product ether. It gives rise to alkene, because the substitution does not take place. In that case, it favors the which type of reaction? Elimination reaction. So this is the correct order of a reactant which gives rise to this product. Fourth part, 1-methoxyethane, which is the word root here. Ethane is the word root. So make 2 carbon, and 1-methoxy means on the first carbon. This is the first carbon, this is the second carbon. On the first carbon there is a substitute, that is a methoxy group, that is OCH3. So first you have make the structure. Now look, find out which are the 2 R's here. This is the 1 R, this is 1 R, R dash. How you can identify? Point out the oxygen, check on the either side. So which are the 2 alkyl groups? That is ethyl and methyl are the 2 groups. Now one can form is due to sodium alkoxide, the other can form that is a halide. So what will be the correct one? That is this and this. So sodium ethoxide plus 1 bromomethane give rise to this product. So nothing here. In this type of problem, the product is given to us, we are identify the reactant, and because since it was given that the Williamson synthesis should be used in order to prepare this type of ethers. So first of all, always identify, first make the structure, point out the oxygen, check on the both the side which is the alkyl group, and on the basis of this what the general equation you have learnt, that is RONA plus XR dash give rise to ROR dash. So on the basis of this, once this you have compared with the product, so you can easily identify which part is the R and which part is the R dash. So you can easily frame the product like as it is given. So this is the method and you have to follow that method also. That is tertiary halides does not undergo substitution, it undergoes elimination. So you should not give the tertiary halide here in the case of Williamson synthesis. So this is all about the question 24, which is based on the ethers. So thank you.